The S3-87 is a clone of the Neumann U87. It's sold as a do-it-yourself kit by microphoneparts.com, and this is the microphone that you are listening my voice coming through now. The entire building and testing procedure took me 9 hours, and I think that is a quite demanding and fiddly work for a newbie, especially in some of its parts, but in the end it's feasible. Once I got the minimum set of tools to start soldering and keep a safe working environment, I broke the two PCBs out of their frame. In order to split the boards without damaging them, I used a box cutter to score along the grooves and a side cutter to break the PCB out of their frame. After that, I filed the boards down to smooth the rough edges where are the perforated attachment points. Then I used a paper towel dampened with isopropyl alcohol to clean the boards. I sorted out the resistors for the two PCBs according to their value, and I placed them on the PCB with the value forwards, so it can be seen once the resistor is placed. To easily solder the components, Microphone Parts recommends you to secure them on the PCB with small pieces of scotch tape, like a painter's masking tape, and not to bend the leads under the PCB but leave them lined up. Otherwise, it's harder to remove the components once it's soldered in case of a mistake or if the component is damaged. After a double check of the right displacement of each component on the board, I soldered them. After soldering, I trimmed the leads. The solder joints should look pretty short after clipping the leads, so that the cleaning procedure is easier. After I soldered the resistors on the second PCB, I cleaned the boards with alcohol to remove the flux residue. I scrubbed the boards with a towel, then with a toothbrush I removed the stray of cotton fibers that invariably remain hooked on the edges of the joint. When all the solder joints looked neat, I placed the inductors. I cut the leads and tested the ground connection from the inductor with a multimeter. Then I moved to the diodes. I wrote their values and installed them. The components should not be forced to fit the holes if they can't, so it's better to repeat a band again if the first is not correct. The following step was the capacitor's installation. Then the vertical resistors installation. For the transistor installation, I used needle nose pliers to bend the middle pin. And then I installed another polarized capacitor, placing it according to the marks on the board. The next component was the socket for the removable capacitor. This allows you to change the circuit frequency response, and we can choose among several equalization curves by using different values of capacitors. Then I placed the transistors and the trimmer, and as usual I soldered the joints after the recommended double check. Other two electrolytic capacitors, and then one of the most tricky parts: the installation of some components with a suspended leg, because we want that the high impedance section do not be on the circuit board. There is a transistor with a suspended leg that is going to intersect the suspended leg of a resistor, and a capacitor close to the other two components with a suspended leg as well. No part of the suspended legs must touch the board. As usual, I cleaned the boards and removed the flux. Then I checked the solder joints and eventually I fixed some errors. The JFET and resistor suspended legs lean on an insulated terminal that must be cleaned and tinned in advance before placing it on the board. I bended the JFET and resistor legs around this terminal and trimmed only the JFET exceeding leg. Then I placed the pad switch, I trimmed some of its pin and placed the suspended legs against two of the switch pins. After the pad switch, I installed the pattern switch. Then I assembled the two boards together. Here I made two mistakes. First, I soldered one board not perpendicular and flat on the other board. And second, I forgot to solder one of the 7 joints that you have to do. This caused the problem that we will see later. And then the most difficult part for me, the capsule installation. The capsule must be set firm on a saddle with 2 screws, and we don't want to touch the capsule on the diaphragm. Instead, we can only touch it on its rim. Until the capsule is disconnected, either side can be front. Further, the capsule can be mounted in one of two different orientations. I had some hard times finding the right screws and the favorite orientation that was the one giving me the longer cable for the later connection. I connected the two back plates together with a piece of wire. I tried to attach the capsule to the circuit. I chose to protect the capsule with the microphone breadbasket during the next part. Unfortunately, I couldn't solder the blue wire to the circuit with the microphone base connected, so I decided to remove that temporarily. The blue wire was too short for an easy soldering. It was a fiddly process that took me much more time and trials, but at the end I succeeded in my goal. I checked the continuity, then I cleaned the joint and I removed the stray of cotton fibers. During the trimmer calibration, my inexpensive multimeter gave me a value that was too high for the circuit, so I calibrated the trimmer according to the alternative way described in the manual. Everything looked fine, but no sound came out from the microphone. So I checked the continuity for the XLR connection and inspected the circuit until I found the problem. I had forgotten to solder these two pads here. After I fixed the problem, the microphone worked fine. The last step was to apply the conformal coating on the high impedance part of the circuit.